In this example, we want to estimate the mean maximum heart rate for people who shovel snow manually versus those who shovel snow with an electric snow thrower. So let's remind ourselves that we are trying to estimate for a population mean. And we actually want to do it for two different populations, the manual snow shoveling method versus the electric snow throwing method. But the notation is mu, so we want to figure out what is mu. And notice that in this problem, the population standard deviation, so population standard deviation, which is sigma, is unknown. So anytime that we don't know what sigma is, we must always use the t distribution. So the t distribution means we need to know our degrees of freedom, which we call df. And there's a simple formula for that, which is simply n, where n is the sample size, minus 1. So here, notice that we've got some sample statistics. I've got some sample statistics for the manual snow shoveling method and the electric snow throwing method. So we've got the maximum heart rate for manual snow shoveling is 175 beats per minute, and for the other method, 124 beats per minute. Our sample size is 10, and then we've got our sample standard deviation of 15 and 18 for each method. Okay, we're going to construct a 95% confidence interval to estimate for the mean maximum heart rate for each of these methods. And so let's go ahead and write down some more information here. Again, our degrees of freedom is n minus 1. So since the sample size is the same for both, we're going to use a degree of freedom of 10 minus 1 or 9. Okay, our confidence level is 0.95, which means our significance level alpha is 1 minus 0.95 or 0.05. And then from here, let's go ahead and calculate alpha divided by 2, which is 0.05 divided by 2 or 0.025. So here we're going to calculate our critical value, but our critical value, instead of being a z-score, it's going to be you can think of it as a t statistic or a t-score. And to find this, you can either use table A3 or you can use your calculator. So I'm going to sketch the t distribution here. And again, it looks a lot like the normal distribution, but I'm going to emphasize the tails being a little bit fatter. And my critical value is t sub alpha divided by 2. So here, t sub alpha divided by 2 is t sub 0.05 divided by 2 or t sub 0.025. So it's the t-score that separates an area or a tail region on the right, where that region on the right has an area of alpha divided by 2 or 0.025. So if you're using the table, I'll show you that in the next slide, how to use the table to get the critical value, but we can also use inverse t here. So just like how you use inverse norm when you're on the normal distribution, you can go to your distributions on your graphing calculator, but this time we would choose inverse t because again, we're using the t distribution, not the normal distribution. So I'm going to use inverse t. You're going to type in the area to the left. So the area to the left is just 1 minus the red region. So 1 minus, you can either type in 0.025 or you can type in 0.05 divided by 2 and have your calculator type that in. And then it's going to ask you to put in your degrees of freedom. So here we would put in our degree of freedom, which is 9. And when you press enter, it's going to give you a critical value of 2.26. So that's what I'm going to use to build my confidence interval. So I'm going to do it for the manual method. I'll just call it manual method versus electric snow throwing method. And that confidence interval is going to be x bar, okay, minus our margin of error. And then the upper confidence limit is x bar plus the margin of error. And again, we'll do it for both methods. So I need x bar for the electric method, and then I need x bar again, but then plus the margin of error. Okay, so I need to figure out what the margin of error is. So again, there is a formula for calculating the margin of error, but that formula is going to be slightly different when we're on the t distribution. So we're going to use the critical value of t sub alpha divided by 2, And we're going to multiply it by our sample standard deviation because we don't have sigma, so we're going to use S instead, and divide it by the square root of n. So here for, I have to do it for each method. So on the left here, I'll do the manual method, and on the right, I'll do it for the electric method. So our critical value is 2.26. Right, for the manual method, that sample standard deviation is 15, so 15 divided by square root of 10. And then actually, let me just write down here, this is E sub m, so we know that that's the error for the manual method, and then E sub E, which is the electric method, because I'm kind of running out of space here. So that's going to be 2.26 times, and then the sample standard deviation for the electric method is 18 divided by the square root of 10. Okay, so the margin of error for the manual method is 10.72 beats per minute, and then the margin of error for the electric snow throwing method is 12.86 beats per minute. So now let's go ahead and subtract that 1072 from 175 for the manual method. So 175 minus 10.72. And then to get the upper limits, 175 plus 10.72. And then let me go ahead and do that for the electric method, but using the sample statistics for that data set. So that's going to be 124 beats per minute minus 12.8. That's going to give us the lower limit, and then 124 plus 12.8 to get the upper limit. So using a blue pen here, the confidence interval for the manual method, that lower limit, is going to be 164.28 beats per minute, and the upper limit is 185.72 beats per minute. And the confidence interval for the electric method, that lower limit is 101.2 beats per minute, and that upper confidence limit is 136.8 beats per minute. So this means that we are 95% confident that the mean maximum heart rate for people who manually shovel snow is slightly higher. So you can see that that number is slightly higher than the mean maximum heart rate for those using the electric snow thrower. And we can say that because if we take a look at the lower limit for the manual method, that's 164 beats per minute, which is higher than the upper limit of the confidence interval for those using the electric snow thrower. Here, I'm going to show you how to use your calculator to find the confidence interval when the standard population standard deviation is not known. So again, we're using the t-distribution. For the manual method, using this sample data, what you're going to do is you're going to press stat. And then once you press stat, you're going to tab over to tests, and then you're going to choose the test called t-interval. So interval meaning that you want to build a confidence interval, and t because you're on the t-distribution. So notice your calculator is going to ask you to put in the sample mean, sample standard deviation, sample size, and your confidence level. And hopefully you'll see that it gives you a confidence interval that is very similar to the one that we got when we used the formula. And then I would just repeat the process for the electric snow throwing method. So again, this time we put in the sample data for the electric snow throwing method, same confidence level, and then hopefully you can see that when you press enter, it gives you a confidence interval similar to the one that you got when we used the formula. And that's how you would use your calculator.